Good morning, class. Today's video is about lesson 10-2. So we're going to start off with the tip chart. We're just going to add a little bit to the term base. Today we're going to be talking about trapezoids, kites, and rhombi. And the bases of a trapezoid are the parallel sides. Pardon my smudge right there. I messed up and tried to erase it. The parallel sides of a trapezoid. So the bases of a triangle, the base of a triangle or a parallelogram can be any side. Depends on what corresponding height they're giving you. And for a trapezoid, it's got to be the parallel sides. I didn't give a lot of room here for drawing a trapezoid, so I'm just going to draw a little trapezoid right here. This is base 1. This is base 2. There are two bases of a trapezoid, the parallel sides. Okay, we are done with the tip chart. So the next thing you will need is you will need the notes page for 10-2. At school, I would have copied this front to back like this. On Google Classroom, I put both pages there, and so you may have printed it front and back, you may not have, but it's there in Google Classroom for you. All right, so I'm going to leave off the date and what class it is just because I may use this video for another class. And let's get started. Okay, so the first thing you'll need is the area formulas for these shapes. The area of a trapezoid is 1/2 times the sum of the bases times the height. And the area formula for a rhombus or a kite is 1/2 times diagonal 1 times diagonal 2. So in this formula, those two D's right there mean diagonals. Okay, since this is all multiplying, you could multiply this in any order. So I've seen on some formula sheets, they'll put the height right here, and they'll say the formula is half the height times the sum of the bases, and that's a fine way to write it because multiplication is commutative. Okay, here's an example. This would be a trapezoid problem that they would give to even younger grades because everything is in its place. So the first thing you do is you write down the formula, 1/2 times the bases added times the height, and then you just plug everything in that they gave you. 1/2 times base 1 plus base 2 times the height. And following the order of operations, you do inside parentheses first. 1/2 times 13 times 7. And then you can multiply these if you want and then take half of it, or you can do half of 13 times 7. So whichever order. Remember, this is commutative, so you can multiply in any order. So 7 times 3 is 91, and half of 91 is 45.5. Let me make sure I did that right. Yep. So the answer is 45.5 centimeters squared. Next one. Find the area. Always write down the formula. This is a trapezoid still. B1 plus B2 times height. Plug in the values that you have. Base 1 is 6. Base 2 is missing right now. So we'll come back to that part. I'm just going to leave a spot for it. And then the height is 4. So the formula tells you what you need, and I need base 2, and base 2 is not there. So I need to do a little calculating to find base 2. So up here, this distance right here is 6. Well, you can grab that and slide it straight down and move it to here. This is 6. But that's not the whole base. That's just from this point to this point. To get the rest of the base, we can use this right triangle right here. Now, some of you may notice that there's a 4 for a leg and a 5 for the hypotenuse. So this is a 3, 4, 5 right triangle. That's the advantage to memorizing those Pythagorean triples that I was telling you about. So this is a 3. If you did not recognize that that's a 3, 4, 5, then we would call this X, or whatever letter you'd like to call, whatever variable you'd like to call it, and do the Pythagorean theorem. So subtract 16, and you get 9. And then square root, and you get x is 3. So using the Pythagorean theorem, you can find out that that distance right there is 3. So I'm going to move that for a minute. That whole base is 9. Half of 15 times 4. Since 4 is even, I'm going to do half of 4 is 2, and multiplied by 15 is 30. 30 feet squared. So this would be kind of a lower level trapezoid problem. This is a 10th grade level trapezoid problem because you have to use all this right triangle work to get that missing value. Example 3. So some people don't like it when their trapezoids are drawn that way, so you can always turn it and face it this way if you want. This problem is very similar to the last one we did. There's some missing values that we need. So I'm going to write the formula here. Area equals 1/2 bases added times the height. Okay, let's see what we've got. We've got base 1 is 12. We don't have the entire base 2, so I'm going to hold off on that one for just a minute. And we don't have the height, so I'm going to hold off on that. All right, so now I have some things I need to find. If this is 12, I can do like I did on the last one and just drag that down. And this distance here is 12. And then I've got the entire base. A 12 and a 6 makes the base 18. And then this height, it's missing. And you may, excuse me, you may recognize that this is a 6, 8, 10 triangle. And if you don't recognize that, then just like the last one, we'll do the Pythagorean theorem to get that value right there. So x squared plus 6 squared equals 10 squared. That's 36 and 100. Subtract 36 and you get 64. Square root, you get 8. So that's a 6, 8, 10. You have half of 20 times 8, that's half 20 is 10, and 10 times 8 is 80. 80 units squared, because they did not tell us what these were measured in. Okay, now we're to some rhombus kite problems. So the formula is 1/2 diagonal 1 diagonal 2. So for these shapes, you need the 2 diagonals. Now, this rhombus is also a parallelogram. So if they had given you the base and had given you the height, we could calculate this area with base times height. So it all depends on what they give you. There are rhombus problems that you can use the parallelogram formula for if you have the right information. So let's use the information we have here, which are about the diagonals. If that distance is 3, using the property of a rhombus, this distance is also 3. And so that makes that diagonal 6. And then to get this other diagonal, since there are no values there, then we're going to use these right triangles. So one property of a rhombus is that their diagonals are perpendicular, which means these are all right triangles. And with this being a 3 and this being a 5, it must be a 3, 4, 5. So this is a 4. Now, if you didn't know the 3, 4, 5, you would have done this work here. It would be x squared plus 3 squared equals 5 squared. So since that one's 4, then this one's also 4, and that whole diagonal is 8. And half of 6 is 3, and 3 times 8 is 24. 24 units squared. Example 5. Same formula. If at any point you want to just pause the video and do the problems on your own and then press play to make sure you got them right, then that is a good way to learn. You can do it that way if you prefer. So if we're looking for diagonals, if this is 6 and it's a kite, and just like a rhombus in a kite, the diagonals are perpendicular. And one property of a kite is that a kite will fold in half one direction. So one diagonal is a folding line. This diagonal right here is a line of reflection. It's a folding line. So this one's not. This one, you can't fold it down like that. But this one, you can fold it over. So if that's a 6, so is this. That whole diagonal is 12. And this diagonal, they're giving us here on the outside of the drawing. So this diagonal is 16. Half of 12 is 6, and 6 times 16 is 96. Let me make sure I did that right. 60, 36, yep. And that is units squared. And that's how to find the area of that kite. By the way, this is not an 8 and an 8. The whole thing is 16, but we don't know how it's divided. A kite, this diagonal is cut in half on a kite, but this one's not. So we needed that value. Okay, next trapezoid problem. So I write down the formula first. 1/2 bases added times height. All right, so let's see what we've got. We've got base 1. Base 1 is 5. So 1/2 times 5 plus, we do not have base 2 right now. And we do not have the height. Excuse me, guys. So we need to do some work on this and find these missing values. So I'm gonna draw this line right here. Now the reason I did that is because they're giving me this 45-degree angle, and they don't give you that 45-degree angle for no reason. They give you that 45-degree angle so that you can make this 45, 45, 90 triangle here. And if you drop a straight line down to between those bases, just like this line here, it's gonna make a right angle. So I've got myself a 45, 45, 90. And this is 10 radical 2. And if you think back to 45, 45, 90s, the template would tell us that this is A, and this is A radical 2. So if A radical 2 is 10 radical 2, these are both 10. And now I've got myself the height. And I've got part of this base. And then I still don't have the whole base yet. I have this part's 10, this part's 3. I'm gonna grab this 5 from up here, and I'm just gonna pull that straight down and put the 5 right there. And now I've got this whole base. It is 18. So this gives you half of 23 times 10, half of 20, let me make sure I did that right, yep. And so that'll be 5 times 23, which is 115. Let me check myself there. 230, 115, yep. 115 units squared. And then the last problem on the notes, it's a rhombus problem. So you write 1/2, diagonal 1, diagonal 2, 1/2. Let's see what I've got. I've got this distance here is 10 radical 3, and I need the whole diagonal. In a rhombus, both diagonals are cut in half. So if this is 10 radical 3, so is this part. So that makes 20 radical 3. 10 radical 3 plus 10 radical 3 is 20 radical 3. And then I don't have any information about this diagonal, but I do know that that's a 30-degree angle, and these are right triangles. So this is a 30, 60, 90 right triangle. And in chapter 8, we learned this template. This is A radical 3, this is twice A. So if A radical 3 is 10 radical 3, then A is 10. That makes this value 10. And then I've got this whole diagonal is 20. So when you multiply this, you get, I would do half times 20 is 10, and 10 times 20 radical 3 is 200 radical 3. and you can leave your answer just like that, units squared. If they were to ask you to round this answer, then you would just punch that into a calculator and you would get the approximate answer, which would be 200 radical 3, 346.4. So it all depends on the directions. Okay, so one thing I want you to notice as I'm going through these problems is I always write down the formula. And the reason I do that is because formulas drive these problems. Formulas are the boss. So when you write it down, the formula tells you what you need from the picture. So it gives you a starting place. So always write down the formula, always put what you can find in the spot in the formula where it goes, and if there's anything missing, well, that's what you need to do the work on to find. So that's how area formulas work. Always write down the formula. Okay, that is the end of lesson 10.2, and there is an assignment on lesson 10.2. The rest of this video is just, I'm going to take some time to go over some problems from lesson 10.1, and I may go over some problems from the last quiz too. It just depends on how long this video is going. The longer it goes, the harder it is to, oops, excuse me, did not mean to do that. Then the harder it is to upload it. Okay, so problems from lesson 10.1. These are just some select questions that may have given you trouble. This was from page 619. So if you did not have any trouble on this, you do not have to watch this part of the video. I promise you will not be quizzed over it or anything like that. This is just in case you missed any of these problems. So I picked out number 9, and it looked like this. And I picked this one because this one is similar to a question that you had on a basic skills test, and some people had some trouble. We did one like this in your notes too. So these were all measured in inches. All right. So the formula for a parallelogram is base times height. There are 3 numbers here, so obviously one of them is extra. And so we just have to find the ones that are base and height. Well, since there's a right angle right there, that's the clue that this is base and this is height. This base matches this, so 4.7. So your base and height are 4.7 and 5.7. 4.7 times 5.7. And since it's base times height, you just multiply those. 4.7 times 5.7, you get, oh, I was going to put approximate, but it's equal to 26.79. Okay, that's number 9. Number 11. Number 11. Looks like this. That's an 8, that's a 10, that's a 14. And then you have this kind of funky extension out here. There's a right angle there, and that is H. Okay, this is one of those problems where they're asking us to find H. And if you look at all these numbers, you'll see we've got 2 different base height combinations. The 14 and the 8 go together. And the 10, if the 10 is a base, then this H is the height from that base. That right angle can be moved to right here. So 10 and H is another base height combination. So if you're using that shortcut that we talked about last class, or last video, I should say. Here's that shortcut. Then the base times height, 14 times 8, that base height combination would have to equal this base height combination. So 14 times 8 is one pair, and 10 times H is the other pair. And you get, let's see, 80 and 32, which is 122 equals 10H. Let me make sure I'm right. 80, 32. No, that's a 112, isn't it? Yeah, sorry guys, 112. Divide by 10, and you get 11.2. And then number 15. So these are just some problems I selected. 15 is a right triangle, and it's drawn like this. This is 7.5. This is 6. This is 4.5. These are yards. And the base and the height would be 6 and 4.5. So area is 1/2 times 4.5 times 6. Remember, the legs are the base and height of a right triangle. So you can just do 3 times 4.5. You get 13.5 yards squared. I forgot to put my units on the last two. This would be inches squared. This would be units squared. Okay, number 16. Now remember, if I'm doing problems that did not give you trouble, you can just zoom on past that part. 2 feet, 3 feet. This is also 2 feet. This one I picked because sometimes people get confused. Is this the base of the triangle or is 4 the base of the triangle? But the base of the triangle is just this part right here. You may be wondering, why did they give me that part? I think it's probably just to see if you know what the base is. So it gives you an opportunity just to clarify. So 1/2 base times height. So 1/2 times 2 times 3. It's always nice when there's a half a 2 in there. So that's just 3. 3 feet squared. And then number 19. Number 19 looks like this. This is 8. This is 8. This is 14. And since this was the lesson before trapezoids, I think they meant for you to find the area of this part and the area of this part and add them together, because we had not done the lesson on trapezoids yet. So if you already knew the formula for trapezoid, you may have used that. But here's what they decided to do. They did base times height on this part, because that is a square. That would be 64. And then for this part, since this is 8, you can just slide that right on up. And so this part right here is 8, and that makes this a 6 to make that total of 14. And so now we can do the triangle. 1/2 base times height. 1/2. The base and the height are going to be 6 and 8. And that is 24. So that's this part. So the total area is 88. And this one was measured in centimeters. It's a 64 plus a 24. If you knew the area formula for trapezoid, you could have done that instead. Okay, I picked out 3 more. Number 21. Number 21 says the area of a triangle is 108 inches squared. And the base and the height are in the ratio 3:2. So I start by writing the formula because I see those words, area of a triangle, 1/2 base times height. And if we don't know the base and the height, but we know they're related in this ratio, I can call the base 3x and I can call the height 2x. So 1/2 times 3x times 2x. And I know what the area is because they told me it's 108. So this is what that looks like. And you get 108. This is half of 6x squared. This right here, 3x times 2x is 6x squared. Half of that is 3x squared. And then you divide by 3. And you get x squared is 36. And let me make sure I'm right there. 90 and 18, yep. And then you square root, and you get x is 6. Now, that is not the base, that is not the height, that is x. So remember, these are our base and height. So 3 times 6 is 18, and 2 times 6 is 12. So those are our base and height. And 2 more, number 35. 35 said to graph this line right here, y equals 3/4 x minus 2, and then graph y equals -2 and graph x equals 4, and find the area that's bounded by those lines. So -2, and then that's where this line starts. And then this is the slope. Rise 3, run 4. 1, 2, 3, 4. So right there. So there's that line. And y equals -2 would be this line. Remember, hoi vux, it's horizontal. And then this line would be x equals 4, which is this one. Same reason, hoi vux, that's vertical. So this is the area that they want. We just need base and height, because it's 1/2 base times height. The base would be this distance, 4 units. And the height would be this distance, 3 units. So 1/2 times base times height would be 6. 6 units squared. And then the last problem I picked out is number 41. And the drawing looks like this. This one is a tough one, I think. So it's kind of a funky drawing like this. These are both 25 feet. This is 25 feet. And these are right angles. Okay, I had to think about this one for a couple minutes. So the problem was we didn't know how this 25 was divided. So we really don't know we can't use this, base and height because we don't know this. And we can't use this base and height because we don't know this. And we'd only be guessing if we divided this 25 up into parts. So the reason that they gave us that this distance right here is the same as this distance is because we can pick that triangle up and we can slide it down and join it to this one down here. So I'm going to take that triangle right there and I'm going to pick it up and I'm going to slide it and join it to this guy. Like that. And that 25 matches up with that 25. So now I'm really finding the area of this triangle. And if you'll notice, the base didn't change. When I picked this triangle up, that base moved to right here. So if that was 25, this is still 25. It just moved. So my base and height are 25. 1/2, area equals 1/2. Base times height, so it's 1/2 times 25 times 25. And 25 times 25 is 625. And then you divide that thing by 2, and you get 312.5 feet squared. And that is how to do number 41. Okay, I think I'm going to stop there, mostly because I need a break, you guys need a break. But remember, you don't have to watch these, all the problems that I do, just only the ones that gave you trouble. And I think I'll do a little review of that last quiz on a different video just so I can upload it. All right, y'all have a great Friday, and I hope you're enjoying learning this way, especially since you can kind of learn at your own pace and you can kind of zoom through things you don't need. And remember, if it's better for you, pause the video, do the problem your own self, and then press play, and that might be better. So I hope y'all have a great day. Bye.